Hello. This video is about separation of variables, which is a technique that we can use to solve certain types of differential equations. The differential equations that we can solve using this technique are called separable. A separable differential equation has the form y prime, or dy over dx, equals some function of x times some function of y. Let's practice identifying which differential equations are separable. For this example, we want to examine each of these differential equations and circle the ones that are separable. If we look at part A, we have a function of x plus a function of y. But in order for a differential equation to be separable, we need to have a function of x times a function of y. So letter A is not a separable differential equation. Letter B, we have a function of x divided by a function of y. At first, we might think that this is also not separable. However, we could write it as x times 1 over y. And now we have dy over dx equals a function of x times a function of y. So letter B is a separable differential equation. For letter C, we must rearrange it before we can recognize that it's separable. We can rewrite the y prime as dy over dx, divide both sides by x, and we have y times the natural log of x divided by x. This can be expressed as y times the natural log of x divided by x. And once again, we have dy over dx equals a function of x times a function of y. So letter C is separable. Letter D, if we solve for y prime, or dy dx, we have cosine of x minus sine of y. This is the difference between a function of x and a function of y, not the product of a function of x and a function of y. So letter D is not separable. Let's talk about the technique of separation of variables, now that we've practiced identifying separable differential equations. The first step is to separate the y's and the x's to different sides of the equal sign. This is the whole reason why these differential equations are called separable. We can separate the two different variables. Once we've successfully separated the variables, the next step is to integrate both sides, and then finally, we try to solve for y. Here's a simple example that we can work through to see how this technique can be used. The first step is to separate the variables. We will take the dy over dx, and we will think of this as a fraction. Multiply both sides by dx, and we will have dy equals x squared times the square root of y times dx. Now divide both sides by the square root of y, and we have successfully separated the variables. We have y's on the left-hand side of the equal sign, and we have only x's on the right-hand side. Now that we have separated the variables, we integrate. This is the second step of the procedure. This first integral is the same as the integral of 1 over the square root of y, dy, and the integral of x squared is x cubed divided by 3. The antiderivative of 1 over the square root of y is 2 times the square root of y. This is equal to x squared, x cubed divided by 3. And we add a plus c on one side of this equal sign. If we solve for y, we divide both sides by 2. We have x cubed divided by 6 plus c over 2. And since c is an arbitrary constant, c over 2 we could just rewrite as another arbitrary constant. Square both sides to solve for y, and we have y equals x cubed divided by 6 plus c quantity squared. That is the general solution to the differential equation, which we found using separation of variables.